Learning objectives. By the end of this course, you should be able to apply the appropriate actions when navigating in ice, taking into consideration ice climatology, analyze ice classification, operate and prepare the vessel in all aspects to navigate safely in ice without the assistance of icebreakers, and operate and prepare the vessel in all aspects to navigate safely in ice with the assistance of icebreakers. Section 1. Introduction. Section 2. Ice climatology and classification. Section 3. Ice navigation independently, without icebreaker assistance. And Section 4. Ice navigation with icebreaker assistance.
Section 1. Introduction. Introduction. Due to the opening of some new oil or gas facilities inside or close to the Arctic Circle, crew members should be aware of the specifics of ice navigation and related procedures, as well as how to prepare the vessel's equipment and crew when traveling in ice conditions at sea. Ice navigation is a specialized branch of navigation that involves the use of maritime knowledge to locate and track ships in frigid waters where ice poses a threat to their safety. A ship must take precautions when there is sea ice present, such as avoiding icebergs, traveling slowly through a lead, or working with an icebreaker to chart a passage through the ice to a certain location. Section 2. Ice climatology and classification. Ice climatology and classification. When a waterborne vessel passes through sea ice, ice navigation occurs. The Baltic Sea and Canadian navigation waters are two of the most frequently used areas for ice navigation. In the winter, ships traveling to the Baltic states or Canadian ports will frequently navigate through first-year ice using icebreakers or information from meteorological offices such as ice reports, charts, and data. In addition, as a result of oil and gas extraction in places like the Yamal SPG project, more ships are passing through the Arctic Ocean during the summer months for leisure and cargo transportation. On the surface of the ocean, sea ice is just frozen seawater. In the winter, it forms in both the Arctic and the Antarctic. In the summer, it retreats, but does not totally vanish. Sea ice is incredibly dynamic, giving rise to a vast range of ice types and features due to the influence of winds, currents, and temperature changes. Icebergs, which are pieces of glacier or ice shelves that carve into the ocean, can be compared to sea ice. Icebergs may also be present in sea ice expanses, depending on the location. Sea ice can be categorized based on whether it is fastened to the shoreline, between shoals, or grounded icebergs. If it is fastened, it is referred to as landfast ice, or more commonly, fast ice from fastened. On the other hand, and in contrast to fast ice, drift ice is found further offshore in very vast areas and refers to ice that is unrestricted by currents and winds. The fast ice boundary is the actual separation between fast ice and drift ice. The drift ice zone can also be broken down into a center pack, a marginal ice zone, and a shear zone. Drift ice is made up of floes, which are isolated chunks of sea ice 20 meters, 66 feet, or larger in width. Click on the numbers to learn more. Small floes range in size from 20 to 100 meters, 66 to 328 feet. Medium flows range from 100 to 500 meters, 330 to 1,640 feet. Big flows range from 500 to 2,000 meters, 1,600 to 6,600 feet. Vast flows range from 2 to 10 kilometers, 1.2 to 6.2 miles. And giant flows range from more than 10 kilometers, 6.2 miles. Either way, the word pack ice is used to describe drift ice. Note: 1 mile equal to 1.609344 kilometers. Grease ice. Seawater freezes more slowly than fresh water because of its salt component, starting at a temperature of roughly minus 1.8 degrees Celsius. Frazzle ice, which consists of tiny needle-shaped ice crystals that grow at the surface and collect to give the water a slushy, hazy appearance, is the first sign of ice formation. This stage is known as grease ice. Click on the next and previous buttons to learn more. Neelers. When the water is calmer, these tiny crystals can condense into a thin surface layer known as neelers, which can grow up to 10 centimeters thick. Pancake ice. Neelers can be broken up by wave movement into small mats that are 1 to 2 meters across, which collide and produce pancake-shaped forms with raised edges. Ice flows. If the temperature stays low, the pancake ice solidifies into ice flows, creating an impermeable surface over the ocean. The ice flows then combine to form ice fields. Large pieces of ice that break off from glacier are known as icebergs. Calving refers to this action. Although they are formed of frozen freshwater rather than saltwater, icebergs float in the ocean. A piece of freshwater ice longer than 15 meters is called an iceberg. The majority of icebergs in the northern hemisphere come from Greenland Glacier. Click on the button to learn more. Non-tabular icebergs feature uneven shapes like rounded tops, spires, slope sides, and blocks. Whereas tabular icebergs have steep sides and a flat top like a plateau. Icebergs are sculpted into magnificent forms by wind and water erosion. There are many different shapes of icebergs. Icebergs come in a wide range of sizes. Click on the next and previous buttons to learn more. Growlers refers to small bergs, about the size of a vehicle, whereas berggebiet refers to slightly larger bergs, about the size of a home. These come in different sizes, small, medium, large, and very large. And they can grow to be enormous. In the North Atlantic, the tallest known iceberg rose 550 feet, 168 meters, above sea level. The entire iceberg was believed to reach the height of a 55-story structure, because most of an iceberg is below the ocean. Iceberg size classifications according to the International Ice Patrol. Iceberg B-15 was half a mile thick and over 4,500 square miles in size when it calved off the Ross Ice Shelf in Antarctica in 2000. It was about the size of Connecticut. Later, B-15 disintegrated into smaller fragments with the names B-15A, B-15B, and so on. Why did this enormous berg split in two? 6 days prior to the incident, an Arctic storm was to blame, according to seismic records. The storm caused B-15 to continually crash against the coast and generated ocean swells that traveled more than 8,000 kilometers. The shape of icebergs presents another way to group them. Non-tabular icebergs feature uneven shapes like rounded tops, spires, sloped sides, and blocks, whereas tabular icebergs have steep sides and a flat top like a plateau. Icebergs are sculpted into magnificent forms by wind and water erosion. Although icebergs are often white, some can be blue or even green. The microscopic air bubbles that are abundant in ice scatter all color wavelengths equally, giving the substance a white look. The ice appears blue when compressed because the bubbles are expelled and blue light scatters more than other hues. Sea ice and icebergs frequently have algae growing on their undersides, creating green stripes that are only visible when the ice rolls over and reveals the previously submerged areas. Knowledge check. Should light and partly loaded ships be ballasted as deeply as possible? Select the correct option and click the Submit button. That's right. You selected the correct response. What is sea ice? Select the correct option and click the Submit button. You did not select the correct response. The correct response is, sea ice is frozen sea water. Select the correct statement. Select the correct option and click the Submit button. You did not select the correct response. The correct response is, sea ice is not the same as an iceberg. What is the air temperature, in degrees Celsius, when superstructure icing is possible? Select the correct option and click the Submit button. That's right. You selected the correct response. Section 3. Ice navigation independently, without icebreaker assistance. Ice navigation independently, without icebreaker assistance. Experience has shown that ships without ice strengthening equipment with an open water speed of about 12 knots can become utterly trapped in heavy concentrations of relatively light ice conditions, whereas ice-strengthened ships with sufficient power should be able to advance through first-year ice concentrations of 6 by 10 to 7 by 10. These ships can frequently move forward with only routing recommendations. Most vessels should be able to maneuver slowly around the floes in open pack ice in concentrations of 6 by 10 or less without coming into touch with very many of them. Click on the button to view the remark. Ice concentration refers to the amount of an area covered by ice relative to the total area of that region. It is usually expressed as a percentage, or a fraction between 0 and 1, or as a ratio in tenths ranging from 0 by 10, no ice cover, to 10 by 10, completely covered by ice. Approaching the ice field. When approaching an ice area, it is very important to observe the ice well in advance. The success of unassisted ice navigation depends greatly on ice chart information. This information should be plotted on the navigation chart as well. Permission by the icebreaker or the Ice Operations Center to enter with relevant recommendations should be obtained. Click on the button to learn more about signs of approaching ice. Signs of approaching ice. Ice sky. White sky above the horizon. Swell decreasing far from shore in case of strong wind. Significant decrease in temperature, if sailing in mid-latitudes. Appearance of separate ice floes, from lee side. Refraction. You can see ice in the sky at a distance of 2 times the range of visibility. See birds, sea animals, etc., about 12 miles to the ice edge. Fog close to the ice edge. Radar use. One radar should be adjusted at short range, always to observe the ice picture. Remember the radar picture in the daytime, it might help at night. Reliable use of radar for ice navigation is possible when deck officers have appropriate experience and within distances not exceeding 5 nautical miles. It is possible to select the way through ice floes only at a distance of 2 to 3 nautical miles, and the type of ice could be determined only in close proximity to the ship. Sometimes, even heavy ice could be mistakenly recognized as open water. A radar can be useful in identifying ice, however, the signal that is returned from ice, including icebergs, is very weak, and at a much lower level than that returned from ships. The purpose of traditional marine radars is target detection and avoidance. Enhanced marine radars produce a considerably crisper image of the ice that the ship is broadcasting since they have a higher definition image. This picture can be used to determine how much ice there is and what kind of ice it is. Sea clutter interferes with the typical radar's ability to observe in the vicinity of the ship. A brief pulse set on an X-band radar can produce better results. Use of searchlight. Click on the images to learn more. During the nighttime, the ship uses its searchlight and deck illumination. The searchlight is used for detecting the ice edge. When the ship is proceeding in convoy, it should be remembered that the light from your searchlight could easily blind the icebreaker or the ship ahead of you. It is recommended to use the Suez Canal light to illuminate the ice edge right ahead of your ship. Entering the ice. Once inside the pack, gradually increase speed to maintain headway and control of the ship, but do not let it rise over the point at which the ship might sustain ice damage. This will help you avoid the initial impact with the ice. Applying power in places with weak ice, or open leads, pools, etc. requires special consideration since, if the power supply is not turned off, the speed could climb unnoticeably to deadly levels. Click on the next and previous buttons to learn more. Be ready to accelerate to full astern at any moment. Heave to in the ice and keep the propeller turning slowly to keep it less susceptible to ice damage than if it were completely stopped. Blocks of ice will also be prevented from jamming between the blades and the hull. Navigation in pack ice after dark should not be attempted without high-power searchlights that can be controlled easily from the bridge. The ship's rudder and propellers are its most vulnerable components, hence ships should always go amidships when going astern in ice. Ships should only advance astern in the channel that their own passage had previously cut in unbroken ice, if they are compelled to ram ice after coming to a stop. All glacial ice in the pack, including icebergs, bergary bits, and growlers, should be avoided because they are current-driven, whereas the pack is wind-driven. The direction of the stream will determine whether large pieces of old ice are traveling upwind or crosswind. Pressure ridges should be avoided, if feasible, and passing through pack ice, while under pressure is not advised. It could be necessary to stop the ship in the ice until the pressure event is over. A ship that is independently navigating will typically need icebreaker assistance to get released from a besieged situation. However, ships in ballast can occasionally self-freeze by pumping and shifting ballast from side to side, and the ship may only need a little change in trim or list to free itself, particularly in high-friction regions with thick snow cover. In the Arctic, the master may want to hire an ice navigator. Maintaining freedom of movement is the basic rule of good ice navigation. Once a ship is locked, it follows the ice wherever it goes. With or without icebreaker escort, ice sailing may be a tiresome endeavor that takes a lot of patience. The fastest and safest route to port, or to the open sea, when leaving a port, is frequently across an area of challenging ice, whose limits are recognized. Click on the button to learn more. Four fundamental ship handling criteria are applicable in situations with more concentrated ice, according to experience. Keep moving, even if it's very slowly. Attempt to work with the ice's vulnerabilities and movement rather than against it. Excessive speed nearly always leads to ice damage. And be familiar with your ship's maneuvering capabilities. Warning: excessive speed is the major cause of damage to ships by ice. Knowledge check. At what speed can ships without ice-strengthening equipment become utterly trapped in heavy concentrations of relatively light ice conditions? Select the correct option and click the Submit button. You did not select the correct response. The correct response is 12 knots. Ships can find it challenging to navigate through ice waters because they move through the icy, freezing water with a lot of crashing and cracking. The ship's bridge team must exercise extreme caution and pay close attention to the kind, thickness, and placement of the ice in the sub-zero navigation regions when it moves through ice-covered seas at sub-zero temperatures. Click on the Next and Previous buttons to learn more. A deviation from the passable route, caused by any form of error during ice navigation, would waste more fuel and increase the likelihood that the ship would become stranded in thick ice, which would put it in danger and cause damage. In both hemispheres, the presence of ice on the ocean surface represents a significant barrier for ships and offshore operations at high latitudes. Only specially constructed ice-strengthened vessels, or icebreakers with the proper ice class, can break through the sea ice, which is often 2 to 3 meter thick. Therefore, the majority of merchant ships and fishing boats that are not ice-strengthened must avoid all ice waters and sub-temperature regions. Even the most powerful of the icebreakers struggle with ice navigation in numerous locations when the ice concentration and pressure are at their peak. Commercial vessel operations typically include an ice pilot and icebreakers to help navigate the vessels safely through the ice field to and from their destinations in order to prevent such accidents during ice navigation. The crew of the vessel must remember a few more precautions in addition to the presence of the ice pilot on board and the icebreaker's unwavering support while navigating through the ice. Maneuvering in ice. First and foremost, it is crucial to comprehend that ice water must be avoided at all costs if a ship has access to another route. The leeward edge, where the ice is loose or cracked, should be approached at a right angle if ice navigation is necessary. If a flow cannot be avoided while navigating through ice, it should be struck directly with the stem. Keep in mind that a glancing blow could harm the ship's hull or cause the ship to lose course, resulting in another inevitable blow. Always enter ice at a slow speed to prevent harm of any kind. The ship's speed can be increased once it has entered the pack to maintain headway, control, avoid losing all way, and keep the ice flows from closing in on the hull, rudder, and propeller. The rudder should be placed amidships, and the engines should be kept turning slowly forward if the ship is stopped by a large concentration of ice. This will help the ship fall back by washing away the ice that has built up astern. Avoid abrupt course changes while traveling in a tight group while maintaining a sufficient speed to allow for steerage. Full rudder movements ought to be avoided or saved for emergencies only. Golden Rule: 10 miles of clear water are better than 5 cables of ice. It is always recommended to have a way in ice and proceed at a safe speed to be able to return to your initial point at any time when it is required to do so. If you have a choice between ice crossing and passing around ice, the latter choice is always preferable. If you have a chance to avoid contact with ice, try to avoid it as much as possible. Click on the numbers to learn more. The propeller should be rotating during maneuvering in ice, as this decreases the risk of damaging the propeller blades. This is especially important for ships with FPP, fixed pitch propeller. If you want to stop the vessel in heavy ice, then slow down to dead slow astern, but do not stop, and wait until the vessel stops. The propeller blades break or bend easily when the screw is stopped while the vessel is still moving astern. Any change of rudder angle should not be large. Only small angles are allowed to decrease the risk of rudder damage. If the rudder goes to port or starboard on its own, immediately run the engine ahead to wash the ice away from the rudder. Ice bridge danger. It is dangerous to cross an ice bridge between two ice fields because this place could be under great pressure. It is much better and safer to cross the field close to the ice bridge. In case of ice that is compacting, prefer proceeding upwind. Principles of moving in ice. Run the engine astern until clear water is ahead, approximately for one hull length. Easily run ahead with a small rudder angle. Contact ice at slow speed, increasing gradually. Repeat step 1, 2 or 3 as necessary. Turning in ice. The speed should be less than 4 knots at all times. The rudder is put to midship when moving astern. Reverse the engine only when the ship is stopped. Speed. If your speed is 2 knots or less, there is a 90% possibility you will get stuck in ice soon. If the speed is constantly dropping, use another way through the ice field. Select the easiest ice when possible. Always compare the ice ahead and abaft the ship. Remember, vessel vibration and movements in the daytime. Observe and register in memory the ice thickness. It will help you during the night. When you choose to drift in ice or wait, don't forget to make a good cushion of broken ice around the hull. Move repeatedly back and forth to make it. Envisage half a length of smashed ice behind the stern. Try to move every few hours to be sure you can go when ordered. Lookout. Always be on the lookout for leads through the ice, which are passable passages inside an ice field. For safety reasons, more lookouts should be stationed ahead, or at higher ends. To have a better perspective of the ice buildup, conning should be done from the ship's bridge. To prevent a floe from actually moving the stern towards it, keep in mind that the stern must always be watched for rudder movement. It is recommended to post crew right aft these situations with torches, whistles, walkie-talkies, etc. to ensure that the bridge is instantly notified in the event that propeller is in any danger. When it comes to twin-screw vessels, this is crucial. If the ice covers the ship, slow down. Anchoring. Avoid anchoring in areas where there is a lot of ice because the force of the moving ice could damage the cable. When conditions allow, anchoring can be carried out, but it must be done immediately with the main engine on, in light brash ice, rotten ice, or widely dispersed floes. As soon as the wind appears to be moving ice onto the vessel, the anchor should be dropped. It is crucial to understand that ship operations of any kind, under the influence of sea ice, are not only dangerous, but also life-threatening, and the utmost care must be taken while navigating through such ice areas. This is true, even with the introduction of new techniques and technologies for ice navigation, such as radar sensor images, through cloud cover, infrared images, and satellite images for a larger view of the surroundings around the vessel. Knowledge check. What is the first principle of successful ice navigation? Select the correct option and click the Submit button. You did not select the correct response. The correct response is, maintain freedom of movement. What is the golden rule of ice navigation? Select the correct option and click the Submit button. That's right. You selected the correct response. If you want to stop the vessel in heavy ice, how should you operate the main engine? Select the correct option and click the Submit button. That's right. You selected the correct. Section 4. Ice navigation with icebreaker assistance. Ice navigation with icebreaker assistance. An icebreaker is a special-purpose boat or ship made to move through ice-covered seas and open up navigable channels for other vessels. Modern icebreakers are diesel-powered and nuclear-powered. Today, the majority of icebreakers are required to maintain trade routes where seasonal or permanent ice conditions exist. Even though the commercial ships that call on these ports are built to withstand ice, they are typically not strong enough to handle the ice on their own. Because of this, the primary duty of icebreakers in the Baltic Sea, the Great Lakes, the St. Lawrence Seaway, and along the Northern Sea route is to accompany convoys of one or more ships through ice-covered waterways safely. An icebreaker's job is to liberate a ship that has become stuck in ice by breaking the ice around it, and, if required, clearing a path through the ice field. The weakest ships can be towed by an icebreaker under challenging ice conditions. Seasonally, depending on the ice conditions, the Canadian Coast Guard, CCG, operates Ice Operations Centres. These centres collaborate with Marine Communications and Traffic Services, MCTS, centres to coordinate icebreaker assistance to shipping, give up-to-date ice information, and advise routes for ships to follow through or around ice. Ice Operations Centres constantly communicate with icebreakers and keep track of the movement of all shipping within their purview. Masters must report to the Canadian Coast Guard before their ships reach waters where ice may be present in order to get the most from the service. The Canadian Coast Guard Ice Operations Centres will continue to keep an eye on the ship's progress as a result of these first reports and following position reports from ships. Communications. For ice navigation to be effective, communication is essential. The master depends on getting reliable ice knowledge and counsel so that judgments can be made about future routes and advancing through ice. Reliable communications are also necessary for effective icebreaker support and assistance to shipping. The guidebook contains comprehensive information on communicating with Canadian Coast Guard icebreakers. Both the Northern Canada Vessel Traffic Services and the Eastern Canada Vessel Traffic Service System, collectively referred to as NORDREG Canada and ECRIG Canada, are required vessel traffic services. Along with providing navigational data, these systems also notify mariners on ice conditions, vessel route, icebreaker assistance, and other Coast Guard services. It is strongly advised that vessels participating in the ECRIG or NORDREG traffic systems report position, ice, and weather information in order to maintain a current and accurate picture of the ice conditions. For various marine areas, marine forecasts are often prepared 4 times per day. The forecasts, which cover wind, visibility, freezing sprinkling, and temperature, are accurate for 2 days with a 3rd-day projection. A maritime synopsis, or summary, which includes the progress of weather systems and current advisories, is provided along with the forecast. When specific meteorological conditions are satisfied, special maritime bulletins are released. According to the schedules listed in the most recent edition of the annual publication, Radio Aids to Marine Navigation, Part 2, these are aired by Marine Communications and Traffic Services Centres. Facsimile weather charts are also used to convey weather information over high and low radio frequencies. Products include prognosis charts, as well as charts that analyze the current weather conditions. For information on Environment Canada programs, including the list of charts and their transmission timings, mariners should check the most recent edition of the yearly publication Radio Aids to Marine Navigation, Part 5. Knowledge check. What is an icebreaker? Select the correct option and click the Submit button. That's right. You selected the correct response. Modern icebreakers are diesel-powered and nuclear-powered. Select the correct option and click the Submit button. That's right. You selected the correct. Where are icebreakers primarily deployed? Select the correct option and click the Submit button. That's right. You selected the correct response. Why is communication essential for safe ice navigation? Select the correct option and click the Submit button. That's right. You selected the correct response. Types of ice pilotage. Individual escort of a single ship. Escort in convoy of 2 ships or more. Close couple towing for ships which do not have enough engine power or hull strength to proceed in ice on their own. Meeting. Sometimes there is a necessity to pass the ship on the opposite course in the ice lead. In this case, one of the ships uses the existing lead, and the other has to make a new one. Loaded ships are recommended to break out of the ice lead, while ships in ballast are recommended to use the existing ice lead. There are 2 methods of meeting. One when the ship leaving the lead stops its engine, and the other when the ship does not stop its engine. In the first case, the ship leaves the ice canal in the area of friendly ice and waits for the other ship to pass. As soon as the ship using the ice lead passes more than half of the ship waiting outside the lead, the latter runs its engines astern and enters the lead again. Ice convoy with icebreaker. Click on the images to learn more. Ice convoy with heavy icebreaker. Vessels should follow at a distance, since, often, quite large and heavy ice pieces could come out of the icebreaker propeller with excessive velocity. The average size of this ice is 10 meter round, 0.6 meter thick, and it weighs around 45 tons. When you catch it with a relative speed of 10 knots, it's more than enough for damage to occur. The relative speed in this case is your speed, plus that of the icebreaker propeller. Light icebreakers follow a nuclear icebreaker, usually just to break ice, to an acceptable size. Ice convoy with small icebreakers. Small icebreakers sometimes work in pairs, to cut channels wide enough for a big vessel. Small icebreakers are easier to stop an occasional heavy ice, but you cannot stop your own heavy ship. Close-coupled towing. Towing by the icebreaker is used when the engine power of the ship is insufficient for ice navigation, or when navigating in compacting ice. The towing wire is sent through the anchor lead and fastened to the bridle on board the ship. In rare cases, the towing wire may be fastened directly to bollards.
Summary. In this course, you have learnt what actions to take when navigating in ice, taking into consideration ice climatology, how to analyze ice classification, how to operate and prepare the vessel in all aspects to navigate safely in ice without the assistance of icebreakers, and how to operate and prepare the vessel in all aspects to navigate safely in ice with the assistance of icebreakers.